Hey Red Wing students, today we are looking at 2.7. So what we see today is we're using formulas solving for a specific variable. So where this confuses us is the fact that we've got two variables present. We are asked to solve for A, but there's also a B hanging around. Okay, now this throws us off. We're not sure if this changes our steps. We get stuck on what to do first. What can we combine? What can't we combine? Do we have to divide by that 2 at some point? No. So the one thing that we've got to keep in mind is whenever we're solving for a variable, all the same rules apply. This would be the same exact scenario if we were solving this equation over here. 5a minus 2 equals 15. Just get that b out of there. That's not going to change anything. My first step would be to add 2 to both sides, which I am pretty confident you guys would all be able to figure out. And then we've got 5a equals 17, and in order to finish, we divide both sides by 5. And that would leave us with a. In this case, it's going to be a decimal, a little ugly, would be 3.4 or 3 2/5. So you can do that. You get it down to a single number answer, which we're used to. Now, what's happening with this scenario is I am not going to be able to get a nice answer like that, but I can still solve for a, and all my steps are still the same. Okay, so over here where I added that 2b first to start getting the a by itself, I added the 2, I'm sorry, I'm going to do the same thing and add 2b to both sides. It's the same step. You'd use the inverse operation to completely move that term over to the other side. So it cancels out completely. You're not dividing by 2. You're going to cancel out completely by adding it over. Now, the only difference is I am not going to be able to combine this 15 and 2b like I could do this 15 plus 2. That's the only difference. So I'm left with 5a on the left, and I'm going to be equal to 15 plus 2b. I can't combine them. One's a variable term, one is a constant. So they just have to stay that way, and that's fine. That's okay. That step is where we struggle here, is we're not sure if we're okay to do that. So then in order to finish, just like I did on the right-hand side, I'm going to divide by 5. I have to get that a completely alone. Now where you have to make sure that we're carrying this out correctly is dividing everything on the other side by 5. The entire equation has to be divided by 5. So I've got a all by itself. 15 divided by 5 is going to give me 3. And then that 2b over 5 can't be simplified any further. It's just going to be 2/5 b. And that's, I think, how you're probably going to see it on Alex and in your textbook or your notes more often. I think you're going to see it as 2/5 b. This would also be correct. 3 plus 2b over 5 to leave it exactly like you left it up as you had it up here. That's correct as well. I think you're probably going to see this version more often with that 2/5 fraction out front of the b. Okay, so that one's done. Yes, this is an ugly answer. No, it is not a single number or a single term or digit. That's fine. We got a alone. We follow the same solution steps. And we'll look at something similar again here. So once again, now we're looking for x with a y present. Again, nothing changes as if you just had a 7. In order to get that minus 7 out of here, you would add 7 to both sides. The only difference today, and we've seen it a little bit already, is that there's a y along with the 7. Doesn't matter. We're not concerned with that y. We are not going to divide by -7. That's not happening. Okay, we're not trying to get the y alone. We just got to get everything away from that x. We are trying to get that x term alone so I can divide and finish. So adding the 7y to the left-hand side will cancel it out. I've got 3x on the left. And again, you cannot combine these two. They are just going to stay as is. 26 plus 7y. That's all you can do. Everything is away from the x. We just can't combine them. One is a constant, one's a variable term. So now I'm going to go ahead and finish by dividing by 3. I have to remember to divide everything by 3. Everything on both sides. So I'm going to cancel that 3 out. X is all alone. Then this one's a little bit more ugly because 26 over 3 is actually going to be 8 2/3 or 8.6 repeating. You don't need to do that. It's actually going to be easier for you if you can't simplify this. For example, 27 over 3 would be that complete or that whole number 9. If you can't do this, just leave it as is. 26 over 3 plus 7/3 y. We can't simplify either of those. If this was 6y, over 3, you could then say 2y. But we can't simplify it to a whole number, so these two things are just going to stay fractions. Okay, as long as they're simplified fractions. Okay, Alex, I think, will accept this. They just ask you to simplify it as much as possible. If you're left with something like 10 over 4, you can't turn that into a whole number, but you can simplify it to 5 over 2. So that would be an example of simplifying. We just can't turn it into a whole number, and that's fine. Alex will take this, and honestly, this is going to save you any extra effort, this answer that we've got boxed out for the final answer. That's all you can do there. Okay? Number 3, we got a word problem. The word problems here aren't doing anything different than what we've already got. Unless you're asked to create an equation first and then solve for a variable, we're just doing the same stuff over and over. Locate that variable that you're being asked to solve for and follow our same steps. The formula for the surface area of a regular pyramid is S equals 1/2 P times L plus B. This is a period, so don't let that throw you off with the S. S represents the surface area, P represents the perimeter of the base, L represents the slant height, and B represents the area of the base of the pyramid. So this is a real formula. This is a formula that you would use as we move down the road. So what we're going to be doing, excuse me, used for surface area, what we're going to be doing is solving for that P. So you're going to run into situations where you maybe got a pyramid where you know all the information except for P, and we're going to go ahead and solve the equation for it. Okay? So what we're looking at, I'll rewrite this, S equals 1/2 P times L plus B. Now this one's a little bit different because there's multiple things happening to this P that we need to solve for. It's both being multiplied by 1/2 and by L. Okay? So what we're going to do, we're going to save this guy for last. We just need to get that B out of here first. So what I'm going to do is I'm going to subtract B from both sides. And what I'm left with then is S minus B is equal to this big term with the P in it. 1/2 PL. Okay. Now technically we could get this 1/2 and this L out of here at the same time, but we'll go one at a time just so that we can see how each of these cancel out. So let's look at the 1/2 first. Let's get the 1/2 out of there. So if we've got 1/2 P, how do I get rid of a fraction out front? Well, a lot of us would say, well, I divide by 1/2. You're right, but how do we divide by fractions? We don't divide by 1/2. We divide fractions all the way back to when you learned this. We divide fractions by multiplying by the reciprocal. So I'm going to multiply by the reciprocal, which is when you flip it, and it's going to be 2 over 1, which is just 2, right? If I double 1/2, that gives me 1. That's what I'm trying to do. So if I multiply this entire term by 2, it's going to cancel out the 1/2, and then I've got to make sure I'm multiplying by 2 on the other side. So I'm going to erase this just to give us our room back here that we need. Okay. So if I multiply by 2, that's going to cancel out. I just have to make sure I multiply the entire left-hand side by 2. It's not just going to be 2s minus b. It's going to be 2s minus 2b, right? When I distribute that 2 through. When I make sure that I multiply the entire left side by 2. Now that that's gone, I've still got this L under here. Okay? We only canceled out the 1/2. So now I've got 2s minus 2b equals p times L. And my last step to get that p alone, again, with two variables next to each other, they're multiplying. I am going to divide by L. Just like I would divide by 3 if I had 3p, right? I'm going to divide by L. It will cancel it out. And you can just leave it as this entire side divided by L. Because you're not going to be able to simplify either of these. There are no other L's. We can't simplify any further. So all you're going to have, what you're going to see here for your final answer is going to be 2s minus 2b all over L, because I can't simplify any further, is equal to p. That's going to be your final answer. Again, these answers are going to look messy, but it's just because we don't know what all these variable terms represent. I follow the same steps I would if there were numbers involved. I just can't combine these terms because none of them are like. An S, a B, and an L for variables represent three different things. We can't combine them. Right? Okay, another one similar to this. Fewer variables, so we should be okay here. Carter is creating t-shirts for a pep rally. The total amount of money Carter collected from t-shirt sales is T equals 14.95x plus 19.95y. T represents the total number, the total amount of money Carter collected. X represents the total number of short sleeve t-shirts. Y represents the total number of long sleeve t-shirts. Okay. Looks like I deleted the steps here, or not the steps, but the directions. But we are going to solve this for Y. Okay. So this is saying if I know how many short sleeve t-shirts he sold and the total amount of money, I should be able to figure out why. Well, in this case, we don't know any of that yet, so the variables are sticking around. So I've got T equals 14.95x plus 19.95y. Okay? So I need to start getting this y alone. This, even though there's decimals and it looks a little ugly, this is the same situation as these first two we looked at. There's two variables, and I've just got to get one of them alone. Okay? So what I'm going to start doing, just start moving towards that y expression, that y term, I should say. We can't do anything to get y completely alone until that piece is alone. The first thing I need to do is fully remove everything that does not have to do with the y term. So I am going to subtract this 14.95x from both sides, minus 14.95x. Okay, that's going to cancel. And then I am going to have to leave it uncombined. I can't combine the t with the x term because they're different variables, okay? We're still following the same steps. They're just not able to combine into one piece. So I've got t minus 14.95x is going to be equal to now just that y term, because that whole x piece is canceled out, 19.95y. Now I'm one step away from getting that y alone. And like we would do with any other number out front, we had our 2y, I'd be dividing by 2. You've got 19.95y. So I'm going to divide by the 19.95. That's going to cancel out. And you can just divide this entire side by 19.95. If you have an entire expression like this t minus 14.95x, more often than not, it's probably not going to be pretty. So you can leave it as is. T minus 14.95x all over 19.95 is going to equal y. And that's all I can do here as well. So that is done. My y is all by itself. Again, it's an ugly thing left over on the left-hand side, but that's what y is equal to when those variables are still hanging around. Okay? Oh, I had that problem on the next slide for us. Solve for y. Okay, so that's all we've got for today. Just keep in mind the fact that you are solving the same steps, or following the same steps, using the same process that we would if there was only one variable. We just can't combine as many times or as many different pieces. Okay, so I hope this helps. Let your teacher know. Let us know if you've got any questions. And good luck on the 2-7 assignment.